Something impossible was detected beneath Antarctica, a signal traveling upward through the Earth itself, not bouncing off the atmosphere, not arriving from space, but emerging from below through thousands of kilometers of solid rock. Scientists didn't expect it. In fact, according to everything we understand about physics, it shouldn't exist at all. So the question becomes unavoidable. What could possibly generate a signal from beneath the most isolated place on Earth? And more importantly, what else might be hidden there? Antarctica is often described as a frozen desert, empty, silent, lifeless. But that description hides a deeper truth. In many ways, we understand the surface of Mars better than we understand what lies beneath Antarctic ice. Entire regions of this continent remain unmapped, not because we lack technology, but because reaching them is almost impossible. Kilometers of ice form a barrier so thick that it has effectively sealed whatever lies beneath from direct human observation, which leads to a disturbing possibility. We are not just looking at ice, we are looking at a cover. At its thickest points, Antarctica's ice sheet reaches nearly 5 kilometers deep, towering higher than most mountain ranges on Earth. This single continent holds around 90% of all the ice on the planet, along with nearly 70% of Earth's fresh water. But more than that, it functions as a perfect preservation system, a natural vault frozen in time. Everything beneath it has been locked away for millions of years. Landscapes, ecosystems, even atmospheric records remain untouched, and isolation over that scale doesn't just preserve history, it creates something far more unsettling: the unknown. When scientists began scanning beneath the ice using radar and satellites, what they found immediately challenged expectations. Hidden beneath the frozen surface were entire mountain ranges, massive structures rising thousands of meters high. The Gombertsa Mountains, for example, rival the scale of the Alps, yet no human has ever seen them directly. They exist in complete darkness, buried under layers of ice that formed long after the mountains themselves. This discovery forces a deeper question. If entire mountain systems can remain hidden, what else has escaped our detection? And the mountains were only the beginning. Further analysis revealed vast valleys and enormous canyons stretching across the subglacial landscape. Some extend for hundreds of kilometers, others plunge deeper than the Grand Canyon itself. This was not a flat, frozen continent. It was a rugged, complex world concealed beneath ice, a terrain shaped by ancient geological forces, now completely inaccessible. But perhaps the most unsettling part is not what was found, it's how recently we found it. For most of human history, this entire hidden world was completely unknown. Then came one of the most controversial discoveries of all. Beneath the ice, scientists identified vast bodies of liquid water, subglacial lakes completely sealed off from the surface. The most famous among them is Lake Vostok. Hidden beneath nearly 4 kilometers of ice, it has remained isolated for at least 15 million years. No sunlight, no atmospheric contact, no known interaction with the outside world. By every traditional definition, this environment should be sterile. And yet, the deeper scientists investigated, the more that assumption began to collapse. When researchers analyzed samples associated with this hidden lake, they found something extraordinary: microbial life, organisms surviving in total darkness, without photosynthesis, without any reliance on sunlight. Instead, they draw energy from chemical processes, adapting to conditions once thought completely inhabitable. This discovery doesn't just expand the limits of life on Earth, it breaks them. Because if life can exist in complete isolation, under extreme pressure, in total darkness, then the boundaries of habitability become far wider than we ever imagined. And that realization leads to an unsettling question. If life can survive beneath kilometers of Antarctic ice, cut off from the surface for millions of years, then where else could it exist? Not just on Earth, but beyond it. Suddenly, Antarctica is no longer just a remote continent. It becomes an analog for other worlds, moons like Europa or Enceladus, hiding oceans beneath ice. Environments once dismissed as lifeless may, in fact, be active. Antarctica becomes a window, not just into Earth's past, but into possibilities far beyond it. But Antarctica doesn't reveal its secrets easily, because beyond the physical discoveries, something even more difficult to explain began to emerge. In recent years, a scientific experiment known as ANITA, designed to detect high-energy particles from space, captured signals that defied expectations. These weren't ordinary detections. They appeared to originate from beneath the ice, not above, not from space, but from below the surface of the continent itself. And that's where the mystery deepens into something far more complex. These signals behaved like neutrinos, particles capable of passing through entire planets without interacting with matter. But what scientists observed didn't align with that behavior. Instead of passing through Earth and continuing into space, these particles seemed to emerge upward, as if they had traveled through the planet and exited via Antarctica. According to established physics, this should be nearly impossible. The probability is so low that it challenges the very models used to describe particle behavior, which forces a difficult conclusion. Something about this environment is not fully understood. Whenever science encounters something it cannot immediately explain, speculation begins to fill the gaps. Antarctica, already shrouded in isolation, becomes the perfect setting for these ideas to grow. Reports of unidentified objects moving across the Antarctic sky have circulated for decades. Some are easily explained: optical distortions, rare atmospheric phenomena, or misidentified aircraft. But others remain ambiguous, not confirmed, not fully dismissed, suspended in uncertainty. And in a place where direct observation is so limited, uncertainty becomes fertile ground for mystery. One widely circulated case involved a supposed crash site visible through satellite imagery. Online communities quickly labeled it as evidence of something extraordinary, perhaps even non-human technology. The image spread rapidly, reinforcing existing theories about hidden activity in Antarctica. But when scientists examined the formation more closely, the explanation was far simpler: a natural ice distortion caused by shifting glaciers and wind patterns. The mystery dissolved under scrutiny. And yet, the reaction revealed something important. People expect Antarctica to hide something. That expectation is not entirely baseless. Access to Antarctica is among the most restricted on Earth. Harsh environmental conditions make travel difficult, but beyond that, strict international regulations limit movement across large areas. Some regions are rarely visited at all. This creates the perception of forbidden zones, places that are inaccessible not just because of danger, but possibly for other reasons. There is no verified evidence supporting hidden installations or restricted secrets, but the absence of access creates a powerful psychological effect. It leaves space for questions, and those questions often reach back into history, particularly to one of the most controversial chapters of the 20th century. In 1938, Nazi Germany launched an expedition to Antarctica, exploring a region they named New Swabia. Officially, the mission focused on mapping and territorial claims, but after World War II ended, speculation began to grow. Stories emerged suggesting that remnants of the regime may have used Antarctica as a refuge. Hidden bases, advanced technology, even escape routes deep into the ice. There is no credible evidence supporting these claims. Historians widely reject the idea of secret Nazi installations surviving in Antarctica. But the persistence of these theories reveals something deeper. Antarctica, by its nature, feels like a place where secrets could exist undetected. Its isolation, its scale, and its inaccessibility create the perfect environment for speculation to thrive. And once an idea takes hold in such an environment, it becomes incredibly difficult to fully erase. Following the war, global attention shifted, but Antarctica remains a point of strategic interest. In 1946, the United States launched Operation High Jump, the largest Antarctic expedition ever conducted. Thousands of personnel, dozens of ships, and a significant number of aircraft were deployed. Officially, the mission was framed as a training exercise and scientific operation, but the scale of the expedition raised questions. Why commit such massive resources to a place described as empty and irrelevant? The answers, at least publicly, remained grounded in logistics and research. But years later, Antarctica again became a focal point during the Cold War. Under Operation Argus, the United States conducted high-altitude nuclear tests, partially using southern regions for data collection. The objective was to understand the effects of nuclear detonations in the upper atmosphere. Once again, Antarctica played a role in experiments tied to global power and scientific advancement. Not hidden, but not widely understood either. Taken together, these operations reveal a pattern. Antarctica was never ignored. It was studied, explored, and strategically considered, far more than its empty continent label would suggest. And as technology advanced, so did our ability to investigate what lies beneath the surface. What was once unreachable slowly became measurable, and what was measured began to challenge everything we thought we knew about the continent. And in recent years, one of the most ambitious mapping efforts ever undertaken focused on Antarctica's hidden landscape. Using satellites, radar systems, and decades of collected data, scientists reconstructed the terrain beneath the ice with unprecedented detail. Tens of millions of data points were analyzed. The result was not just a clearer image, but a completely new understanding. Antarctica was not what we thought it was. Instead of a flat, uniform mass of ice, the continent revealed itself as something far more complex. Beneath the frozen surface lies a chaotic and varied terrain. Mountains, ridges, valleys, and vast networks of geological formations. More than 70,000 subglacial hills have been identified, creating a landscape as intricate as any visible region on Earth. This is not a static environment. It is dynamic, structured, and deeply shaped by forces that continue to operate beneath the ice. And this hidden world has a past that is almost impossible to imagine when looking at Antarctica today. Millions of years ago, the continent was not frozen. It was warm, covered in dense forests, crossed by rivers, and populated by diverse forms of life. Fossil evidence confirms the presence of dinosaurs and plant ecosystems that could only exist in a temperate climate. Antarctica was once part of a completely different Earth. The transformation from that ancient world to the frozen continent we see today is one of the most dramatic environmental shifts in planetary history. Over millions of years, shifting tectonic plates, atmospheric changes, and ocean currents gradually isolated Antarctica and triggered its deep freeze. But this raises an important question. If such a transformation happened once, could the continent be capable of changing again? Beneath the ice, Antarctica is not entirely frozen. Hidden volcanoes, dozens of them, remain active below the surface. Their heat interacts with the ice above, creating pockets of liquid water and influencing the movement of glaciers. These geothermal systems introduce energy into an otherwise frozen environment. And where there is energy, there is potential for life. Not surface life, but hidden ecosystems, completely independent from sunlight. These environments may function in ways we are only beginning to understand. Microbial communities could exist around geothermal heat sources, similar to deep-sea hydrothermal vents. Entire ecosystems sustained not by sunlight, but by chemical energy rising from the Earth's interior. If confirmed, this would redefine what we consider a viable ecosystem, not just on Earth, but across the universe. At the same time, Antarctica holds one of the most valuable scientific records on the planet. Its ice layers act as a chronological archive, preserving tiny bubbles of ancient atmosphere within them. By extracting and analyzing these samples, scientists can reconstruct Earth's climate history with remarkable precision. Changes in temperature, greenhouse gases, and atmospheric composition, all recorded layer by layer across millions of years. This makes Antarctica more than a mystery. It makes it a memory, a record of how Earth has changed, and perhaps a warning of how it might change again, because the data preserved in ice doesn't just tell us what happened, it helps predict what could happen next, and those predictions are becoming increasingly urgent. As global temperatures rise, the stability of Antarctic ice is beginning to shift. Glaciers are moving faster, ice shelves are weakening, and in some areas, melting is accelerating. Regions that have been sealed for millions of years are slowly becoming exposed. What lies beneath them may soon be revealed, not through deliberate exploration, but through environmental change. That revelation carries both promise and risk. On one hand, newly exposed areas could offer unprecedented scientific discoveries, unknown ecosystems, geological formations, or data that reshapes our understanding of Earth. On the other hand, melting ice contributes directly to rising sea levels, threatening coastal populations worldwide. Antarctica is no longer isolated from global consequences. At the center of this growing tension is the Antarctic Treaty. Signed by multiple nations, it establishes the continent as a zone dedicated to peace and scientific research. No single country owns it. Military activity is restricted, resource exploitation is heavily limited. For decades, this agreement has preserved Antarctica as a shared global space, but that balance may not last forever. In 2048, key aspects of the treaty can be reviewed and potentially revised. And as technological capabilities improve, the pressure to access Antarctica's resources continues to grow. Oil, natural gas, rare minerals, materials that could hold immense economic value. For now, they remain out of reach, but in a future defined by scarcity, that may change. Because beneath the ice, Antarctica may hold more than scientific secrets. It may contain resources capable of shifting global power structures. Nations are aware of this. Interest is growing. And while current agreements prevent exploitation, the question is not whether Antarctica is valuable, it's how long that value can remain untouched. And so we return to the question that started it all. Antarctica is not empty, it never was. It is a place where every answer leads to new uncertainty, where discoveries expand the boundaries of knowledge, only to reveal how much remains unknown. Signals that defy explanation, life in impossible conditions, a hidden worlds beneath layers of silence. Because the greatest mystery of Antarctica is not what we have already uncovered, it is what remains beyond our reach, beneath kilometers of ice, untouched, unseen, and still unexplained, waiting not to be found easily, but to challenge everything we think we understand about our own planet.